So in this video, I'm going to try to summarize the concepts of margin of error and a confidence interval in statistics and kind of just explain how they work and what we're talking about when we look at these problems. So in what we call inferential statistics, we attempt to infer characteristics about a population from sample statistics. So that's the whole idea. You're given something from a sample, and we want to see if we can use that to make a prediction about the actual one for the entire population. These inferences always have a degree of uncertainty in them, meaning, we don't always know exactly how accurate they are. So this uncertainty itself is quantified in statistics by what we call the margin of error. So it's a measurement of how accurate we believe our sample statistic is relative to the population. The margin of error allows us to give a range of values, this is where the confidence interval comes in, that are reasonable for a population parameter based on a sample statistic. We will only consider what is known as the 95% margin of error. So you've seen that a lot in questions. I say assume 95% confidence or find the 95% confidence interval. So technically we could be more confident, and if you ever take another stats course, you might talk more about 98 or 99% confidence intervals. That means your margin of error would be calculated a little bit differently. Okay, so let's look at a couple of examples. This first example says, in a sample survey, 50 people, so that's how many people were in the survey, were randomly sampled about their favorite soda. If 19 of them listed soda A as their favorite, then answer the following questions. A says, what is the margin of error for this survey? So since this example is describing the number of people out of a total that liked something, this is a sample proportions problem. So when we go to calculate the margin of error, we want to be using the formula that involves the sample proportion. So if you remember, the standard deviation formula for a sample proportion is big square root of p, or you can use p hat depending on if you have the sample or the population proportion, 1 minus p over n. Okay, so in this case, since they told us there are 50 people in the survey, that's our n. Our p hat, in this case, is really p hat because it came from a sample, is 19 out of 50. So again, sometimes they might present this to you as a percent, but this time they just told us the number out of the total, which is really the same thing as giving a percent, just a different format. So I'm going to go ahead and plug these numbers in. So I think I'm going to go ahead and convert 19 out of 50 into a decimal, because if it's terminating, that's a little bit easier. So that's 0.38. And then I'm going to do 1 minus 0.38 over n is 50. So if you're going to do this all at once in your calculator, you're going to need quite a bit of parentheses. Make sure the square root is around the entire thing. If not, if you're worried about messing that up, I often just do this in steps. So I'm multiplying 0.38 times 1 minus 0.38. I'm getting that answer. I'm dividing by 50. And then I'm square rooting that entire answer. So I'm not rounding anything until the very end. It didn't specify here, but I'm going to go ahead and give that to 3 decimals because that's what we've typically done in class. So that came out to 0.069. Now remember, you were originally asked for the margin of error, and the margin of error is twice the standard deviation. So I now have to take this number and double it. So the margin of error is 2 times 0.069. And that comes out to 0.138. So that is the margin of error, or our wiggle room for this sample. Now it says interpret the margin of error in context. So this means you really want to try to use the scenario that's provided to you to explain this. So what we can say is that the true proportion of people that like this soda should be within 0.138, or you could think of that as 13.8% of the actual percent that was given to us in this problem, which was the 19 out of 50. So I'm going to write that out. So the proportion of people who like soda A is within, or you could say it is blank from the true one, however you want to word that, is within, you could say 0.138, or like I said, you can convert that to a percent, however you want to do it, is within 0.138 of our original sample proportion of what we know 19 out of 50 is 0.38. So again, if you wanted to say that in percents, this really means that the true proportion of people who like soda A is within 13.8% of 38%. So again, in this case, we can't even really use a unit. You could say percent if you wanted to and move your decimal, but we can't really use any unit other than that. So then it says, what would be an acceptable range of values for the population proportion? So you see these words like this, acceptable range of values, 95% confidence. This is talking about the confidence interval. So we're going to take our sample proportion, which was 0.38. Again, that came from the 19 out of 50, just turned it into a decimal. We're going to subtract and add our margin of error to come up with our range. So when I did that, I got 0.242 to 0.518. So I'm fine with you just writing it out like this. You can also convert this to percents. So you could say 24.2% to 51.8%. We can only do that on this particular example because it's about a sample proportion, not a sample mean. You can also write this out using the symbol for population proportion and say something like 0.242 less than p, because lowercase p without the hat on it is from the population, less than 0.518. So any of these would be an acceptable way to represent your confidence interval. So just a regular interval, or interval of percents, or an actual inequality using the sample, or actually the population statistic, I'm sorry. Okay, so that was one example, doing a margin of error and a confidence interval for a sample proportion. Here's another example. It says a consumer group is trying to determine the mean amount that a family of 4 spends on food per week. They perform a survey of 300 random families of 4 and find a sample mean of 241.50 and a standard deviation of 46.72. So those three numbers are really important. So the 300, this is our n. This is how many families were sampled. Here they're giving us the x bar. This is really... this is the sample statistic that we'll be using to build ultimately our confidence interval. And this is the standard deviation. So I'm going to call, I'm just going to go ahead and, yeah, that would be little s because it's from a sample. Okay, so it says determine an estimate for the standard deviation of the sample means. We haven't really looked at this notation. If you remember, sigma just means population standard deviation, and they use a little subscript of x bar to say it's the standard deviation of the sample means. Don't worry about that. You don't have to use that notation. But this is another formula that I know. So the standard deviation when you're dealing with the sample mean is little s over the square root of n. So they told me the sample standard deviation was 46.72. And there were 300 people, or families I should say, in this survey. So I'm going to type this into my calculator. I'm going to again stick with 3 decimal places. And I got 2.697. You can give that a dollar sign if you want to, because we are talking about the average and standard deviation of amounts of money here. What is the margin of error for the mean amount spent on food per week? So now I'm just like I did before. I already know my standard deviation, so I'm going to double it to get my margin of error. So I got 5.394. I'm just realizing as I'm doing this example that it's money, so you really could have rounded to 2 decimals instead of 3, but that's not a big deal. I would specify if this was on a test. So here is my margin of error. And this last piece says, if the World Almanac found that the mean amount spent by all 4-person families in 2015 was 244.90, was this within the margin of error you found in Part B? Explain or show how you arrived at your conclusion. So when they're asking, is this within the margin of error, that means that's kind of, remember the whole idea behind margin of error and how it helps you make a confidence interval. So this would really tell me, find the confidence interval and then see if my values are in there. So find the confidence interval is what this wording would tell me to do. So I'm going to go ahead and again, I'm taking the sample statistic, which in this case is my sample mean of 241.50 that they told me at the beginning, and I'm taking away my margin of error. I'm going to go ahead now and use 2 decimals here because it's money and that makes more sense. And then I'm going to add that number. And this will give me my range of values for the mean amount spent on families. Okay, and so when I did that, I got 236.11 up into $246.89. So again, you can leave that like that, or you can use proper notation, you can still keep the dollar signs and actually turn this into like an inequality. In this case, we're estimating the sample mean, or I'm sorry, the population mean, and we use this fancy M called mu for that, to 249.89. So I found my interval. Again, either of these notations is fine. Although that's not exactly what they asked for. They wanted to know, was the mean amount that the World Almanacs was citing of 244.90, is it within that margin of error? And it looks like it is. $244.90 does fall within here. So the answer to the question would be yes. And the explanation is all right here. It shows exactly how I found my work. So I found the interval, and the amount that they asked about was indeed within the interval. So those are a couple of examples of how we use margin of error and confidence intervals to discuss real-world context, and hopefully that helps.